Okay guys, from our previous video, to quickly recall what we did, we add live server extension to host our static files so we can navigate through our main index.html to each animation we will have in future, and we structured out our root folders. So now let's think about what we need for animations and caching users' interactivity, like mouse events or keyboard events, and add more boilerplate code here for that in this index.html file. At first, I would say obviously we have to have the canvas element. So let's grab that. As you remember, we add this canvas tag with ID canvas, so we can just use native DOM API to query selector and take our canvas element. So next we want to take 2D context from that. 2D context is just an object which has a bunch of functions we will use to draw on our canvas in this 2D space. So let's grab that. I will call it CTX. It's just shortcut of context. Everybody use this name. Nice. These two variables will be global for our file. So as you remember, we use type module, so we don't care about the global namespace inside the file, because of this type module we know that those variables will never end up here in window console namespace, so we won't have clashes. Nice, but we want to keep these two variables global inside our file. So next, to make all things be dynamic, because most animations are dynamic and they use movement, timing and all this stuff, we should use some kind of loop that will depend on time and will run 60 times per second to provide 60 FPS, 60 frames per second. Basically it means that our canvas need to be redrawn or updated, if you will, 60 times per second. I will use request animation frame for that, and I navigate to this article on Mozilla documentation, and what it says that window request animation frame is a method that tells the browser that you wish to perform an animation, and you request the browser. So you want browser to call your function before it will update, it will be repainted once again. Let me quickly draw a plot of what I mean. So we have a browser, and browser have some kind of loop inside itself. So this loop goes 60 times per second. So the browser redraws active tab 60 times per second. It is done to synchronize information user requests and the tab itself, because user can scroll page, navigate through the links, and some elements can be some be created or removed, all this stuff. So browser kind of synchronize all this stuff. So that is why it runs 60 times per second to redraw all this stuff. But we will use request animation frame, and the request animation frame takes a callback as a parameter. What does it mean? It means that when we will use request animation frame, we will pass a function, our function as a callback, and here we will draw our stuff, and as browser goes and before next update, it will look inside requested queue, and it will show it, and it can see that okay, this this function was requested to call before next update. So we will use that. Okay, let's go next. For that we need to create our function. Let's call it loop. So inside this function we will do some drowning. Okay, so then, as I said, we want to use this request animation frame, and as a callback we want to pass our loop function. So if before next update, browser will call our loop function, and this function will be run. But what we need also to do, we need to add this request animation frame here at the bottom of our function. So what does it mean? It means that we will request animation first time, and when we finish with our stuff we will request one more time. So it kind of loop stuff, you know. So actually we don't need this one, we just will call loop. Nice. And also, as I said before, animations deal with time. We need to keep track of timing. So in example it shows that as you pass a callback, this callback will be called and some kind of timestamp will be passed inside. It means that as long as your current tab is active, it keeps track of this time, how long it has been active, and we will use this time, find some kind of progress time, but in game development it is called delta time. Okay, let's calculate this data time. We will use that in our future videos. Let's add it. We will call it delta. Delta means that we need to subtract time. We have current and we will have previous time. Okay, for that we will use, this is just to use some kind of variable, but I will do something like that. It's not a best practice, but I will say previous time. And what we will do, we will say timestamp minus loop previous time. So it will give our delta time. And then we want to save current time as a previous time. Loop. Actually, let's call it current time, or just current time. Current time and previous time. Okay. This is our loop, and we will draw. Let's create function. It will receive delta. Yeah, and basically we will draw all this stuff here. Yes, this function is our main loop. So it will be requested and it will be fulfilled, you know. And this is, and it will each time it will call our draw function, pass delta, and all our stuff will be going here. Nice, it should work. So let's check if it actually works. Let's create test folder, add those files here, save that, and navigate to this file. Yes, we should go, and I called that. Let's go to test. Of course we have some errors. Yeah, why not? Yeah, because we call loop function before we define our draw function. Yeah. Now it should work. So let's look at the delta time we have. We will use that. At some point, you see this is 16 and something. This is just basic value. So if you have 60 frames per second, you will have this constant time. So okay, now we have our loop and draw function. In next video we will add functions to keep track of most commonly used user events, so stay tuned. Like this video and subscribe on this channel.